You've been thinking about queues wrong, not as data structures, as contracts. A queue is the agreement between two parts of your system that don't trust each other. And like any contract, it works exactly as designed, right up until the moment you forget to read it. Today, what that contract actually covers, the failure mode it creates that synchronous systems don't have, and the two questions every queue in your system needs to answer. Let's get into it. Black Friday. An e-commerce team has just introduced an order processing queue. Web servers push orders in, order processors work through them, the traffic spike hits exactly as expected. Producers healthy, response times fast, users happy. From the outside, the system looks perfectly fine. But half the consumer fleet has hit a deployment issue. Processing has quietly halved, and the queue depth starts climbing. 1,000, 5,000, 20,000. After 2 hours, 80,000 unprocessed orders. No alert fired. Queue depth wasn't being monitored. The team found out when customers started calling. Orders placed never confirmed. The backlog took 6 hours to drain once the consumer fleet was restored. Here's the thing. The queue did exactly what it was designed to do. It decoupled producers from consumers so completely that the consumer failure was invisible. That was the problem. So what is a queue actually doing? It decouples producer from consumer in three distinct ways, not as a performance trick, as an architectural contract. First, rate. The producer and consumer don't have to run at the same speed. A spike that would immediately crash a synchronous consumer, it just becomes a backlog. The system absorbs it, as long as the consumer eventually catches up. The queue is the buffer. Second, availability. The producer doesn't need the consumer to be alive. Work lands in the queue and waits. The consumer can restart, deploy, recover without losing a single message. That's the backbone of at least once delivery. The queue is the persistence layer between two unreliable components. Third, knowledge. The producer doesn't need to know who consumes its messages. Add consumers without touching producers. Swap implementations without coordinating a deployment. The queue is the interface. These three properties together make the queue a trust boundary. Each side trusts the queue, not each other. That's why it works. And that's exactly why it can fail invisibly. Here's the insight most engineers miss. A queue doesn't make failures disappear, it hides them. In a synchronous system, consumer slows down, the producer feels it immediately. Timeouts, errors, latency, fast and visible. In a queue-based system, the consumer can fail completely, and the producer keeps running for hours, none the wiser. That's often the right trade. You've swapped an immediate visible failure for a slow, recoverable one. But here's what that trade actually costs you. A new failure mode. One that doesn't exist in synchronous systems. Backlog accumulation. And unlike errors or latency, backlog doesn't fire any alert by default. You have to build that visibility yourself. Every queue needs to answer two questions before you ship it. One, what's the acceptable depth? That's your processing SLA in numbers. Translate it based on consumer throughput and alert when you cross it. 2. What happens when the queue is full? Drop, block, dead letter queue. All three are valid, but making no choice means the answer gets decided for you at the worst possible moment. A dead letter queue is where messages go when they can't be processed. Without one, failed messages either disappear or block the queue indefinitely. If you're building queues today, build the DLQ path into the design. Adding a queue without monitoring its depth is trading a visible failure for an invisible one. The queue is only half the system. The depth alert is the other half. One action before you close this. Pick one queue in your system. Answer two questions. Does it have a depth alert? And what happens to a message that can't be processed? If you can't answer both, that's your next engineering task. Next up, day 6, idempotency. At least once delivery is the guarantee queues give you. But at least once means your consumer will see the same message more than once. Day 6 is about building consumers that can handle that safely. See you there.